WinRM is great, but if you work across Windows, Linux, and containers, then OpenSSH is clearly the better option. Today, I will show you how to set it up on Windows and on Linux. If you have no idea what SSH actually is, no worries, I will explain everything. We'll go from basic password authentication all the way up to certificate authentication. And if you don't know what that means, no worries, I explain the base theory first, then we will dive in setting things up. I will show you the specificities that exist for PowerShell commandlets in regards to OpenSSH. At the end of this video, you will be able to know what the prerequisites are for PowerShell remoting over OpenSSH, how to set things up, which commandlets you can use and how to use them, how to do cross-platform PowerShell communication, and even how to use OpenSSH between Windows systems over SSH. And along the way, I will explain the theory that exists behind the different protocols that are used, and we'll also see the most common pitfalls so that you don't do the same errors as everybody else. If you're new here, my name is Stefan and welcome to my basement. I'm a former Microsoft MVP, conference speaker, and I've been in the sysadmin space for more than 15 years now. On this channel, I mainly talk about sysadmin, scripting, and code. Okay, let's dive straight into it. If we're talking about the nitty-gritty of OpenSSH, for the people that don't know what OpenSSH is, let me explain this very shortly. OpenSSH is a critical tool for administrators, specifically in the Unix and macOS world. It operates on port 22, and this also applies to PowerShell over OpenSSH. SSH has been added in Windows in autumn 2018. This means it is present in client operating systems from Windows 10, Windows 11, and since Windows Server 2019 and above. SSH has two ways of working. One, using a passphrase. Two, relying on public and private keys. How does the client authentication actually work when we use OpenSSH? Before we go into the details of how to set up OpenSSH on a Windows machine, I want to go ahead and explain the theory that relies behind using SSH in general. Specifically, if we're using private and public key pairs. Just so you know, it is also possible to use a password authentication, which I will show you also just a minute. On the SSH client, you go ahead and generate two keys. These keys are commonly known as a public key and a private key. The public key is something you can share, everybody can read it, everybody can know that it exists. The private key, though, is a secret. It should be considered as a secret, and it should never be shared. The public and private key are related to each other. You can go ahead and using a private key, you can calculate the value of the public key, but not vice versa. If you just have the public key, you will never be able to calculate the private key value back. When the server will try to connect to a remote endpoint where OpenSSH is installed, it will go ahead and do a request generally on port 22. When the server receives this connection, the server will go ahead, generate a random number, calculate the MD5 hash of that random number, encrypt the number using the public key of the client, and send this encrypted random number back to the client. Once this client receives the encrypted random number and try to decrypt it using its private key. Once it managed to decrypt it, it will go ahead and generate the MD5 hash of the long number that it just received. They will compare the MD5 hashes that they have. If those MD5 hashes matches the one from the client with the one from the server, then the connection is established and the client and server will trust each other and the communication will be allowed. The connection is then open and messages can be sent between the client and the server. Yeah, and that's it. Hey, sorry to interrupt. Please consider liking and subscribing to this channel. It will send a very positive signal and it will encourage me to create more content like this. So now that we've seen it, let's see how we actually go ahead and install OpenSSH on a server and on a client and how we configure it. So there are two scenarios here I would like to cover. One, the connection of using OpenSSH on the Windows perspective, and the second part will be the Linux perspective. So on a Windows server, the prerequisites are minimal. You need to install the OpenSSH feature. So if you take a look now, you can see that we have two optional features available. We have this OpenSSH server and the OpenSSH client. You have to install the OpenSSH server on the system that you would like to connect to remotely, your destination host. The OpenSSH client is the optional feature that you need in order to be able to establish a connection. But nonetheless, the client should be installed by default. We are going ahead and installing the server version here. And that's basically it. If we have a look at the firewall rules, we can see that it created an inbound rule for port 22 on TCP, which is the default port of OpenSSH. It additionally installed a service called SSHD, D for daemon. Daemon stands for service in the Linux world. So that service is by default stopped. We need to start it, enable it, and set startup type to automatic. As soon as we start the service, we can go ahead and have a look at C program data /SSH. And in there, we're going to have a lot of files that are automatically going to be created. These files are important in order to be able to configure the different options of OpenSSH. Within all those files that have been created in that folder, there's one that is pretty important for us, sshd_config. This file allows us to configure all the options that are available in OpenSSH. I'll tip, everything in the Linux world is case sensitive. So here we want to configure two things. One, we want to enable the password authentication. And two, we need to add the PowerShell subsystem. And I will come back to that in a second. To enable the password authentication, search for, you guessed it, password authentication. And make sure that the line is not commented and that it is set to yes. Before using PowerShell, in order to use SSH, we can actually use pure SSH if you want to make sure that the OpenSSH communication actually works. This is generally a good practice if you need to troubleshoot remoting problems, issues with OpenSSH. When launching the connection, the first thing that will happen, if it did not already occur, it will present us a key fingerprint and ask us for confirmation to connect. If we say yes, the fingerprint will be added to our known host list. Known host is actually just like the trusted host, but instead of writing down the IP address or computer name, it will add the SA key fingerprint. You can see that we are connected now on the system using raw SSH, and we are actually using a command prompt. If you want to continue to use SSH, but you would like to use PowerShell in your SSH prompt, that is actually possible. We can change that. We simply need to set following reg key, which is a value that points to the path of PowerShell 7. So PowerShell core, or in other words, PWSH. So now let us connect to that remote machine using PowerShell instead of SSH. Do you think that it will still work? Let's give it a try. So the process to connect to a remote machine using OpenSSH is very straightforward. And if you're pretty familiar already with using invoke command, enter PS session, etc., well, you will feel just like home because it uses the same commands. You've learned it once, you can use it multiple times. Starting with PowerShell 6, a new parameter has been added to invoke command, enter PS session, new PS session, and that parameter is called hostname. So hostname is the parameter that you need to use if you want to open an SSH tunnel to a remote machine. PowerShell knows that each time it sees the parameter hostname, it should not use the classic WinRM, WSMan in other words, but it has to use SSH. So let me show this with a concrete example how this works. And so in this example, we can see that I get an error message, subsystem request failed on channel 0. This is a common error that can happen if we do not configure OpenSSH completely. I specifically show it to you because it happened to me and it most likely will happen to you. So this is how we fix it. Simply go back into the SSHD_config file and make sure that a subsystem is actually present in that file. And if it's not, add the following line. You can find everything in the description below into the config file. So once we've added the new subsystem, we need to restart the SSHD service and we can try again. If you have allowed the password authentication and if you've added the correct PowerShell subsystem in the SSHD_config file, then you should not have a problem to connect. Well, you still need to get the password right. And voila, that's it. That's the only thing we need to do in order to be able to connect to a remote machine using OpenSSH. Easy, right? Let's level up our game now. Start to use cryptographic keys. You'll see this feature is pretty interesting, so stay tight. So in order to use public and private keys, we need to tell our SSH server that we actually want to enable this feature. So how do we do that? We go back into our SSHD_config file and we simply say we want to enable it. And we search for pub key authentication. We make sure it sets to yes and that it is uncommented. So let's restart the service and try to connect to it. If we connect now, we can see we have another error message. So no blah blah. Here we can see permission denied, public key. This makes sense as we've never created any key whatsoever. We just enabled the public key configuration in the SSHD config file and that's it. So let's go ahead and create some cryptographic keys. So we need a pair of public and private keys. We can use SSH keygen.exe in order to generate those ones. We can simply leave all the options to the defaults. We can see that SSH keygen generates two keys in the .ssh folder of our documents right here. There is a public key, the ID_RSA.pub, and there's a private key, the ID_RSA. So this private key should be considered as a secret. The contents of this file should be copied out, placed in a credential management system, and this file should be deleted. So we need to bring the public key to the remote server where we want to connect to. I'm here using RDP and simply using a simple copy mechanism. SSH comes with a handy built-in tool called CP, which is a secure copy file mechanism, which is commonly used to bring SSH keys over to remote system. The contents of this file needs to be copied over to our remote system into our SSH folder called authorized_keys. If you want to give administrator access to people using this key, you need to add an additional step and you will need to copy over the contents of this file into another file called administrators_authorized_key. Additionally to that, you need to disable the inheritance on that specific file and make sure that only the administrators and the system account have full control on this file, and set the owner of this file to the local group of this server. Validate everything and restart the SSHD service. I like to test things first using pure SSH. Here you can see I'm using the -I, which stands for identity file, which allows to specify a private key that we would like to use. In this case, I've only one available, so I will point to that one too. You do it. Yes, you know what I'm talking about. Did you subscribe yet? The link is just here below. Thank you. Okay, now that we've tested the connection using SSH, let's go ahead and start using PowerShell and establishing a connection using SSH instead of WinRM. You will see you can actually use the exact same commandlets to manage your connection that you have open using OpenSSH, just as you would with the connection open using WinRM. Possible to use new PS session, and you can specify here the -key file path, which you have to point to your private key. So you can go ahead and create this connection to your SSH server. Now that the connection is established, you can see, if we have a look at the session variable that we created, that the connection is now open and that the transport type is of type SSH. Really cool, right? And we can go ahead and use that session to enter the session using enter PS session, launch a few commands. We can see that it works just as it would with a regular WinRM connection. And once we're done, we can just simply exit this session using exit PS session. And once you're done using this connection, you don't use it anymore. Just as with WinRM, you can go ahead, remove the session using, you guessed it, remove PS session. So passing a key file is the solution. It's simple, but clearly this doesn't scale. Also, it can be a bit annoying if you need to pass the right key to the command each time you want to connect. But without a doubt, it is much easier than to pass credentials each time we want to connect. So we can actually use a command that will add a key to SSH, and SSH will keep it in memory in a secure location. He won't ask for it again in the future. And this command is SSH add. You will see that when we try to connect again, we do not need to use the -i, and we can connect directly without specifying either credentials nor a private key. That's pretty neat, right? Let's have a look and configure partial remoting for Linux systems now. Here we are on our Linux system. This is an Ubuntu server. Let's first make sure that we have installed the SSH client and the SSH server. For that, we use sudo to install OpenSSH client and the OpenSSH server. Now, this is going to be similar on the Windows systems, but we're going to do everything on the Linux system. On your OpenSSH server, so the system to which you would like to connect to, go ahead and open the sshd_config file, which on an Ubuntu system is located by default in e/ssh/sshd_config. So we're now located in Vim, which is a text editor on Linux. It is a bit special, so bear with me if you're new to this. You need to go ahead and do the following two things. One, we want to add subsystem for PowerShell, and two, uncomment the password authentication and set it to yes. So now press escape followed by WQ exclamation point so that you can get out of Vim. Restart the SSHD daemon. Now let's go back on our server and try to establish a connection to this Linux machine. Here we're going to use new PS session. We specify host name and not computer name. So we make sure that partial remoting will open an SSH tunnel and not a WSMan. And we point it to the right server. It's going to ask us if we would like to add the fingerprint key. We say yes. And voila, we're connected. So now in order to connect to a Windows machine from a Linux host, we basically do the same thing again. It is really straightforward. We open a new session using invoke command or new PS session and establish a connection using host name. You specify which username you would like to use. In this case, I'm using a domain account from my Active Directory system. And voila, OpenSSH is now running in your environment, and this is awesome. If you want to see how this compares to the classic PowerShell over HTTP, I recommend you watch this video right here. And if you want to see a super cool technology called WinGet, I recommend you watch over here.